For these, we're asked to complete the square on this, use that type of technique to get through these problems. This one's already set up for you, so we'll get started. I'm going to go ahead and rewrite it. X plus 6 quantity squared equals negative 36. Never do your math on the original problem. Just go ahead and write it out and then work on it from that way. So I'm trying to get x by itself. I use reverse operations or inverse operations to get x by itself. If I was simplifying this, we would use the order of operations, which is parentheses, then exponents, then multiply and divide, then addition and subtraction. For reversing that, there's no addition and subtraction we would do. There's no multiply or divide on the outside. So the first thing is the exponents. We're unfolding it. So I like to think we're trying to get to x. We have to unfold or peel away all the onion slices that's around it, the layers around it. So I need to take off that square first. So what's the opposite of square? Square root. What we do to one side, we do to the other. This is where you have to remember there's a plus and minus whenever you undo a square. Negative 36. This means square root of a negative means we're in the complex field. So we have imaginary numbers that are going to come out. I always try to have that kind of reflex when I see a negative inside a square root. It's easier just to think of it as an I that pops out. So, like I said, a square and square root undo each other, so we're left with x plus 6 equals our plus or minus the square root. Let's take care of that negative first. So that's my trick, is whenever you see a negative inside the square root, it comes out as an I. Try not to overthink it too much. It's a new kind of math for a lot of people, so we just pull it out. All right, and the square root of 36, I'll simplify that, plus or minus 6i. We still have x plus 6. To get x by itself, minus 6 minus 6, x equals, the negative 6 comes out front, plus or minus 6i. This is called like the rectangular form of complex numbers. So it's some number a plus some number b, and then we have that I. So this would be called the real part. It doesn't have the I attached to it. This is called the imaginary part because it does have the I. The whole thing is called a complex number. But we have solved it. So that's our solution. There's two answers. There's the plus and minus. So if we needed to break it up, we could do that, but this looks good for now. So for the next one, they gave us a problem starting from the beginning, and then we'll go ahead and do the same techniques, and it should turn out like this if we land in the imaginary field again. All right, so I'll go ahead, and the book or the program has their way, which they like to move this number to the other side. And then we focus on the x's and then kind of do things to both sides. I want to show you a different trick or technique, the one that I use. So when we do this, we need our complete the square number. So the complete the square number is a special number. It's b over 2 quantity squared. You have to have that formula memorized. This is the one that you have to memorize because you're using this special number to help things balance and get into the direction that we want to go on this. So I'll use my foundation here. Foundation is ax squared plus bx plus c. That's the good thing about not moving it over there is it fits this form a lot better. So b is negative 18, c is 206, and a, I pointed almost to the x, a is the number in front of x squared, so a is 1. I'm not worried about A, I'm only worried about the B here. So hopefully you can see we always look in front of the number to know what kind it is. It's a negative 18. So this means that's negative 18 over 2 quantity squared. This turns into a negative 9. We do the parentheses first this time. and then that gets squared to be 81. Now, I want to bring your attention to this number right here. There's a shortcut that when you complete the square, it always uses this number as part of that binomial. All right, but this is the number that we want to kind of use as our complete the square number as we interject it into the original problem. All right, so here's how I do it. X squared minus 18x. I'm going to leave a open spot here. We still have our plus 206. All of that's equal to 0. All right, now here's my trick. Is I like to add and subtract the same number to this side. So if I need to add or include this 81 here, I want to subtract 81 at the same time, and that keeps things balanced. So you have two options. You can do it to both sides, and that's a popular technique. I like doing it to the same side. All right, so you always use the positive one to match up with this. So I use the positive one. Let's use red. Plus 81. That's what completes the square. And to keep things balanced, I have to subtract 81. So hopefully, to me, this makes a little bit more sense. 81 minus 81, that's a 0. So that's just a legal move in math. It doesn't change the essence of the problem. Now, this right here is our perfect square, and I can combine those. So I like to put a little multiply dot above the multiply number, a plus sign above that one, but it's the same as a diamond problem. We're looking at what numbers multiply to be 81 and add to be negative 18. If you've done it right, it should be the same number. So it's negative 9 and negative 9. My shortcut is, with that and that, it's a little bit easier to see what two numbers multiply to be 81 and add to be negative 18. Negative 9 and negative 9. So this right here changes into x minus 9, x minus 9. And then I have this combining of these integers right here. I'll go ahead and I don't want to make any mistakes on this, so I'll use the calculator. I got 206 minus 81. 125 plus 125. I have more positives here. All that's equal to 0. This is the exact same thing times itself. So that's x minus 9. That's what square means. The exact same thing times itself. Plus 125. And then we got the equal 0 still. Now we want to solve for x. So to me this makes a little bit more sense. I like having all my x's on one side, and that's a real popular technique when you're starting to factor and things are on both sides, is I move everything to one side, deal with it, then I move stuff that I need to the other side. So that means I'm getting x by itself. I move everything else to the other side. And this was what I was saying before about reverse order of operations. In reverse order of operations, addition and subtraction comes first. So I get rid of that plus 25. Minus 125, minus 125. Now I have x minus 9, quantity squared, equals negative 125. And running out of room here, I'm just gonna go right into the solution. So opposite of square as, I don't want to compromise anything. This should give me enough room. So I got x minus 9, quantity squared, equals negative 125. Opposite of square, square root. Square root. What did I forget? Don't you forget that plus or minus. I forgot it on purpose, just to show you. These undo themselves, and we got x minus 9 equals plus or minus, I don't mind doing this in phases since we first started being introduced to imaginary numbers here. So this is square root of 125. The I comes out. Be very careful. A lot of students accidentally keep the I under the square root sign. It's very important that you keep it separate. It's outside the square root sign. 125 is 5 times 5 times 5. So here's my side work. Square root of 125 is 25 times 5, which is 5 times 5. So all of this turns it, let's see. All of this is equal to the square root of 5 times 5 times 5. There's a pair of 5s there. So 1 comes out. Meaning, this is 5 on the out. I'll just write it. This is 5 root 5. That's what that turns into. So then I'll rewrite it. X minus 9 equals plus or minus 5 root 5 I. Get x by itself, we're almost done. Plus 9 plus 9. And I get x is equal to, remember the real part goes in front, 9 goes in front, plus or minus 5 root 5 and I. And everything, that's the original. Everything looks good. Complete the square to solve for x.